Hey y'all, today is April 8th and we are doing a little mini lesson on 8-3, our triangles lesson. And there are three things that I want you to focus on in this lesson. The first one is the angle sum theorem. The second thing is classifying triangles by angles and sides. And the third thing is the triangle inequality theorem. So I've got three little sections in this little mini lesson. So grab a piece of paper, a calculator, a pencil, and let's get started. So part one, the angle sum theorem. The angle sum theorem states that the sum, that means I'm adding, of the measures of the three angles in a triangle is always 180 degrees. So the angles in a triangle, all three of them added together, is going to equal 180 degrees. So we can use this theorem to find missing angle measures. So that's our first objective, find each missing measure. So we're going to find where that question mark is. What is that angle measure? And I'm going to represent that missing angle as x. So I'm going to set this up as 65 plus 57 plus x, and I'm going to set that equal to 180 because all three angles have to add up to 180 degrees. Now, to solve this, first I'm going to combine like terms. So I can combine 65 and 57. And if I put that into my calculator, I get 122. So 122 plus x equals 180. Now, to get that x by itself, I have to undo this 122, and that's a positive 122. So to undo it, I simply subtract 122 on both sides. Okay, so now that I'm subtracting that on both sides, the 122s cancel out, and x is by itself. And on the other side, 180 minus 122 is 58. So that missing angle is 58 degrees. Okay, let's look at number 2. So it looks like I'm missing two angles here. But remember, when you see this little kind of square marking in a angle, it means that that angle measures 90 degrees. So I know that that square means that that angle is 90 degrees. So I actually have two angles that are known and only one that is unknown. So the way I'll set this up is the same way I set up number 1. I'll start with the known angles, so 40 plus 90 plus, and I can use any variable to represent the angle that's unknown. I'll use x, and all of that together has to add up to equal 180 degrees. Now I'm going to combine like terms. My like terms are these just plain old numbers right here. So 40 plus 90. When I add that together, I get 130. So 130 plus x equals 180. Now to get that x by itself, I have to undo this 130, right? That's a positive 130. So I'm going to subtract 130 on both sides of my equal sign. So what happens is the 130s cancel out, x comes down, it's by itself. On the other side, 180 minus 130 is 50. So the missing angle is 50 degrees. Okay, let's look at number 3. So again, I'm given two angle measures and I'm just missing one. So I'm going to set this up the same way. Start with our known angles, 20 degrees. Plus 130 degrees, plus any variable to represent the one that's unknown, and set that equal to 180 degrees. Now we're going to combine like terms, and my like terms are these plain old numbers right here. 20 plus 130. When I add that together, I get 150. So 150 plus x equals 180. Now to get that x by itself, I have to undo this 150, and that's a positive 150, so I undo it by subtracting, and I do that on both sides. So I'm subtracting 150 on both sides. On the side with the x, 150 cancels out, x comes down, it's by itself, and on the other side, I have 180 minus 150, which is 30. So my answer is 30 degrees. That's the missing angle measure. Okay, number 4. So we're given 2 angle measures. We're missing 1. So I'll set this up the same way. Start with what's known. So 85 degrees plus 50 degrees plus I'll use X to represent the unknown angle. And all of that adds up to 180 degrees. Thank you so much. Okay, so now we need to combine like terms. So 85 and 150 are like terms, or sorry, 85 and 50 are like terms. So I can add them together. And when I add them together, I get 135. So 135 plus X equals 180. Now to get the X by itself, I need to undo this 135. It's positive, so I undo it by subtracting. So I subtract 135 on both sides. So on the side with the X, the 135 cancels out. X comes down, it's by itself. On the other side, 180 minus 135 is going to be 45. 45 degrees is my missing angle measure. Okay, so those are our examples for the angle sum theorem. Now let's talk about classifying triangles by angles and sides. So, classifying by angles, you need to know these 3 words right here. That's how we classify triangles by angles. So, acute means all angles, all 3 of them are less than 90 degrees. Obtuse means one angle is greater than 90 degrees. And right means one angle is it's equal to 90 degrees. Okay, now we can also classify by sides. And to classify by sides, we're going to use these 3 words: scalene, isosceles, and equilateral. So scalene right here means that all 3 sides are different lengths. Isosceles right here means that 2 sides are equal in length and only one side is different. And equilateral right here means that all 3 sides are equal in length. All 3 sides are the exact same length. Okay, so we are going to classify the next 4 by angles and by sides. Okay, so number 5. What I noticed right off the bat is I have this square right here. Remember, what does that square represent? It represents that angle right there, let's see if I can do that better. That angle right there is equal to 90 degrees. So if that angle is equal to 90 degrees, which word right here means that we have one angle equal to 90 degrees? If you said right, you're right. So we know that because that angle is 90 degrees, this is a right triangle. Okay, and when I look at the side lengths, they all look different. So this one right here looks really, really short. I've got these other 2 that are a little bit longer. One seems longer than the other. So right scalene. That's how I would classify this triangle here. Okay, let's look at number 6. Okay, so one thing I noticed right off the bat, all of my angles right here and right here and right here look pretty small. Remember, obtuse means that we have at least one angle, or we have one angle that's bigger than 90 degrees, right? And so if a right angle that's equal to 90 degrees looks like an L kind of, right? All of these look a lot smaller than an L. So I would say that all of these are less than 90 degrees. So that means that this is an acute triangle. All the angles are less than 90 degrees, right? Okay. Now, the other thing I notice is these 2 lines right here. Those 2 lines are telling me that this side and this side are equal in length. So if I have 2 sides that are equal in length, what do we call that? Is it scalene? Is it isosceles? Or is it equilateral? two sides that are equal in length is going to be isosceles. So the way I classify this triangle in number 6 is acute isosceles. Okay, number 7. So this is a little bit easier because I've been given all of the angle measures and the side lengths. Okay, so let's start with our angles first. What I notice right off the bat is this right here is bigger than 90 degrees. So I've got one angle that's bigger than 90 degrees. What kind of triangle is this? If you said obtuse, you're right. It is an obtuse triangle. One angle is bigger than 90 degrees. Now, the other thing that I notice is that I've got this side here that's 2.5, let's say inches, and this side here that's also 2.5 inches. So I have two sides that are the same length. And when I have two sides that are the same length, we call that isosceles. So this triangle is obtuse isosceles. Okay, let's look at our last one here. So what I notice right off the bat are my angles. My angles, 60 degrees, 60 degrees, 60 degrees. They're all the same, but they're all less than 90 degrees. So when we have a triangle where all of the angles are less than 90 degrees, we call that acute. Okay. Now I also notice that this side length is 8.6, this side length is 8.6, and this side length is 8.6. So my side lengths are the same. What do we call a triangle where all three sides are the same length? We call that equilateral. And I just want to make a note that all equilateral triangles are acute. All equilateral triangles are acute. Okay? Let's move on to our third section, the triangle inequality theorem. So, the triangle inequality theorem says that the sum of the two smaller side lengths must be larger or greater than the third length. The sum of the two smaller side lengths must be greater than the third side length, which is the biggest side length, right? So we're going to determine if the following side lengths could form a triangle, and we'll prove our answer with an inequality. So for number 9, 3 inches, 4 inches, and 10 inches. Those are my side lengths, right? Well, my two smaller sides. My two smaller sides are 3 inches and 4 inches. So I'm going to use those. So I'm going to add them together. 3 plus 4, because remember it says the sum, that means I'm adding, of the two smaller side lengths must be greater than, so my greater than symbol, the third. So now I'm just going to simplify this. Well, what is 3 plus 4? It's 7. So 7 is greater than 10. Let me read that again. 7 is greater than 10. Is that true? No, that is not true. So because this right here is not true, can these side lengths form a triangle? No. Okay, let's move on to number 10. I've got 5 centimeters, 6 centimeters, and 10 centimeters. So my two smaller side lengths are 5 centimeters and 6 centimeters. So I'm going to add those together. 5 plus 6, and I need to set that greater than 10. Well, what is 5 plus 6? It's 11. 11 is greater than 10. Let me read that one more time. 11 is greater than 10. That's true. So because that's true, can these form a triangle? Yes. Okay, let's look at number 11. So even with decimals, this triangle inequality theorem works the same way. So I need to identify my two smaller side lengths here. Well, the two smaller side lengths are 1.2 millimeters and 1.6 millimeters. So what do I do with those two smaller ones? add them together. So 1.2 plus 1.6, and I set it as greater than the third side length, 3.1. Well, what is 1.2 plus 1.6? It's 2.8. So 2.8 is greater than 3.1. Let's read that one more time. 2.8 is greater than 3.1. Well, that's not true. So because that's not true, these cannot form a triangle. Last one, 6 feet, 8 feet, and 14 feet. What are my two smaller side lengths? Well, they're 6 feet and 8 feet, right? So I'm going to add them together. 6 plus 8 is greater than 14. Well, what is 6 plus 8? 6 plus 8 is 14. So 14 is greater than 14. Let's read that again. 14 is greater than 14. No, 14 is equal to 14. So that is not a true inequality. So these side lengths cannot form a triangle. Okay, so that was a lot of information we covered. Remember, we covered the triangle, the angle sum theorem. We covered classifying triangles by angles and by sides. And last, we covered the triangle inequality theorem. So that's a lot of information you need to know about triangles. I hope you found this video helpful.